Welcome to the chemistry session. In this session, we are going to discuss about the different subatomic particles which are present in an atom. So, as you all know, atoms are the building blocks of matter, but it is composed of subatomic particles which are known as electrons, protons and neutrons. Now let's see how the discovery of electrons, protons and neutrons has been done. Let's begin our chapter. Atoms. These are the building blocks of matter, and it is the smallest unit of matter, which is composed of three subatomic particles, the proton, neutron and the electron. Now, cathode ray experiment. J.J. Thomson discovered the existence of electrons. He did this using a cathode ray tube, which is a vacuum sealed tube with a cathode and anode on one end that created a beam of electrons traveling towards the other end of the tube. The air inside the chamber is subjected to high voltage and electricity flows through the air from the negative electrode to the positive electrode. The characteristics of cathode rays do not depend upon the materials of electrodes and the nature of the gas present in the cathode ray tube. This experiment actually showed that the atom was not a simple indivisible particle and contained at least one subatomic particle, the electron, as you can see in the picture. Now we'll see the properties of electrons. These are negatively charged subatomic particles of an atom. The mass of an electron is considered to be negligible and its charge is -1. The symbol for an electron is E negative. Electrons are extremely small and are found outside the nucleus. The next model was Thomson's model of atom. Now, according to Thomson, an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom is as a whole is electrically neutral. The first model of an atom to be put forward and taken into consideration. He proposed a model of the atom be similar to that of Christmas pudding or watermelon. The red edible part of the watermelon is compared with the positive charge in the atom, and the black seeds are comparable with the electrons which is embedded on it. Now, the radioactivity. It is the term for the process by which an unstable nucleus of an atom loses energy by giving out particles. It does so by giving out particles such as alpha and beta particles, and this process is spontaneous. An atom is unstable if the nucleus has an imbalance, meaning a difference in the protons and neutrons. As you can see in the picture, there is a high energy radiation by the radioactive atom. Now, another famous model is Rutherford model. Now, in this experiment, fast-moving alpha particles were made to fall on a thin gold foil. His observations were a major fraction of the alpha particles bombarded towards the gold sheet passed through it without any deflection, and hence most of the space in an atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume. Very few particles were deflected back, that is, only a few alpha particles had nearly 180-degree angle of deflection. So the volume occupied by the positively charged particles in an atom is very small as compared to the total volume of an atom. This was the Rutherford model of atom. Now there are certain drawbacks of Rutherford model. First, he explained that the electrons in an atom revolve around the nucleus in well-defined orbits. Particles in a circular orbit would experience acceleration. Thus, the revolving electron would lose energy and finally fall into the nucleus. But this cannot take place as the atom would be unstable and matter would not exist in the form we know. So, these are the general models for different scientists who has proposed for the subatomic particles. Thank you, children.